We have Dr.
No, just
Mr.
Marc.
Okay, Mr. Leatham, Marc Leatham. He is here to talk to us about astronomy. And we've been trying to put this together for a long time, but we've had scheduling conflicts, and so we're finally making this happen. So I really encourage you to write down questions as we're going through things to ask him. That's why I asked you to have a pencil. Does anyone need some scrap paper? Raise your hand and I'll pass it to you. Okay. And we can, I got your slideshow, so that's all ready.
Excellent.
Okay. I think we can start. You ready, guys?
Yeah.
Okay. Okay, who needed paper?
I'm gonna use ours.
No, I'm just kidding. I'll go first. She needs to send out I didn't see her hand here. You were so busy wrestling with Aaron.
Oh God, I know. See, even the guy said
Alrighty, I think we're ready. Uh-oh. Can you hear us?
Yes, I can.
Oh, okay.
I just don't know if it's my turn yet.
Okay, yes, go ahead.
Cool. Hey, everybody. So if I get this right, I'm talking to the Salt Middle School, right, in Colorado?
Yes,
All right, now, are you all, I couldn't figure it out from the website, are you all Tauruses? Is that your mascot? Like the bull horns, is that what your mascot is?
sir. Yeah.
The Longhorns, that's what you are. Because I have to admit, my high school, my junior high mascot was a roadrunner bird. And I think that a bull is quite a bit better than a roadrunner bird. So let's just say that you guys got that going for you. First of all, I just wanted to start off by asking, who in the audience here knows exactly what type of career that they want when they graduate high school or college? Raise your hand if you know exactly what you want to be. All right, good, good, good. Now question, keep your hand raised if you know you're going to go to college. Okay, so that's more numbers. That's a good sign, good sign. So I wanted to talk, take like maybe 10, 15 minutes to talk about my path through making those decisions. And right now, it's really early on for you guys. You don't need to know exactly what you're going to be doing with your life. But I just want you to know specifically that I had a hard time with it, and it's okay if you have a hard time with it as well. So, are you looking at Marc Leatham Space Systems Engineer slide? Is that all you see? Just a really boring white slide?
We're just looking at you right now, but I can certainly pull that up.
Okay.
Okay, now we've got your boring slide.
Great. Now, if you move on to slide number 2, that says I didn't know what I wanted to be.
Great.
It has a list of all the different majors that I went through in college. A major is a specialty where you focus on one thing and you're going to get a job in that. I think there's 6 different types of majors. Usually you don't swap around this much. It just goes to show that I had no idea what I wanted to do with my life. And so I went from wanting to design airplanes and then wanting to design circuitry, then programming computers. And then I had a midlife crisis in college, and I all of a sudden decided that I wanted to be a high school choir conductor. Who here does choir? Raise your hand if you're a choir. Yes, bravo. These ladies and gentlemen that sing in choir, guaranteed, are going to have the best time in high school, because that's what I loved about high school. But if you don't do choir, that's okay. I highly recommend you try it though. However, I learned that high school choir teachers don't make very much money at all. So if I wanted to provide for my wife and family, I had to find something else. So I moved on to audiology and speech pathology. Who here has ever went to a special training class to improve their speech? Did anybody see a speech pathologist? Anyone? like have a hard time saying their R's or S's. That was me right up and down the road, and I appreciated that about the lady that would meet with me all the time and help me better communicate. And as you can tell now, I'm okay at it, but I can still do better. But sadly, I was in that program for 3 years, and I realized that when it came down to it, I wanted to do research. I wanted to discover things and not struggle through those classes. So, can you read what the bottom there, the last one on the slide says? Can someone read it for me?
Paula, you got that?
Then finally to Earth and space exploration systems design.
Perfect, nailed it. Does anybody have any idea what that means? Like if you could think of a job that was in Earth and space exploration systems design, what would that mean?
Like you design rockets or something like that?
That's an excellent guess. So, I could imagine someone doing that, but the specialty right on top of that is the only reason you would ever need a rocket is to get something else up into space. And so what I specifically was designing was payloads, the actual satellites and things that would take measurements that would go up into space. And I fell in love. So I was going to class throughout all those different majors and programs. I was sort of just there because, you know, my parents expected me to be there. I was trying to figure out what to do. The second that I found something that really struck my curiosity, I was able to go to class every single day and not fall asleep and focus exactly on what I wanted to do, which was to send equipment on rockets up to space. And so, sadly, I never got to do that in college, but I am doing it now. So if you swap to slide number 3, I don't know if we have an easy way to do that.
Yep, here I go.
So this is a picture of the space station that I'm building. This isn't done yet. They haven't put a space station together, but it's being built on paper. And I actually am the engineer that's responsible for taking these plans and putting it into a computer, and using the computer in a much more efficient way than a typical engineer would use, like blueprints. You know how you see blueprints for a building, it's just lines and letters and stuff? If you can actually put it into a computer, the computer can help you build it. So that's my focus. But this space station, raise your hand if you knew that there was a space station around the Earth right now.
The ISS.
Crazy, right? A lot of people don't realize that there's actually 6 people living in space right now. I think it's 2 Americans, a Russian, a Canadian. I can't remember the other 2, but the amazing thing about this is there have been humans living in space non-stop since the early 1980s. Does that mean anything to anyone? I think it's incredible. Every single time when you just live your life and you go to sleep at night, there's actually astronauts doing experiments and running amazing progress on the International Space Station. And this thing is going 17,500 miles per hour around the Earth. It's staying only 250 miles per hour miles up above the surface, but it's booking all the way around. And so I wanted to work on something that was super intense and highly complicated like that. So I got a job working for Booz Allen, and I'm working on developing a new version of the International Space Station, but only this is going in orbit around the moon. There's never been a space station other than a small little ship with a human in it to be in orbit around the moon. So I'm literally going to work every single day to work on a problem and solve something that has never been done before.
Is this an American initiative or is this an international initiative?
International. So all these, so see in the picture how all the different parts of the space station sort of like dock and they can separate and then come back together. The Europeans have been assigned certain parts of the space station. The Russians have been assigned certain parts of the space station. The Americans at NASA, we're building most of it. However, there would be no way that it would work without the other parts of the space station built by other countries. And so it's really amazing that all of this effort from around the planet is going into this one piece of hardware. The International Space Station technically is the most expensive object ever built in all of history. Over I think it's either 3 or 30 billion, I think it's $30 billion went into building the ISS. So think about yourselves. Do you like working on high-stakes projects? Do you think that'd be awesome, or would that be super stressful? Raise your hand if you would like to work on something super, super expensive. Okay, gutsy guy in the back, I appreciate that. However, I have to admit that when it comes to working on something super expensive, it's really difficult for you to influence a lot of the different parts of the space station. That's why I'm a systems engineer, because I influence a lot. I can influence the requirements for keeping the astronauts alive. I can influence the space station showers. Any small little part of the space station, I pay attention to it. And I love that. That's something that I didn't find in class, and it took me forever to get to a point. However, what I wanted to talk to you about today isn't so much the space station, it's how I explore space myself. I like to consider myself sort of an astronaut. I've never been to space, but I've seen more of space than anybody else, guaranteed in this room, or actually probably at my company here in Los Angeles. So if we can go to slide 4. Are you guys seeing the cactus?
Yeah.
So this is a picture I took while I was camping. This right here is in the middle of the Arizona desert. That's a swirl cactus, and that big old orange glow that's behind the mountain, that's Phoenix. That's the entire city of Phoenix, Arizona, glowing with light pollution up into the sky. Anybody know what that weird looking smudged white band thing in the middle of the picture is?
The Milky Way.
Anyone?
Shout it out.
The Milky Way.
Okay, so we call it the Milky Way, but why does it look that way? Like, why is it a weird stripe in the picture? What's going on? What's the Milky Way?
Trail of stars.
Okay, I heard galaxy in there. Anybody want to elaborate on that?
You can speak louder. Let's raise hands and then I'll follow.
Okay. Just trying to get some
Okay, you know what?
participation
Anyone
here.
just shout out. What did you say, Ashley?
Never.
A trail of stars.
Perfect. So, I just wanted to point out that we live inside of a galaxy, and this galaxy, the Milky Way Galaxy, called the same thing, is a disk. Imagine a big old pizza made out of stars just swirling around in space. It would look really cool, but what would it look like if you were stuck inside of it? Literally stuck inside this pizza disk of stars, and that's exactly what it would look like. That band right here in the sky is just a long road and stripe of the huge city of stars and nebulas that we're stuck inside of. So a lot of people don't appreciate this. You guys, you live in an actually pretty dark part of Colorado. I actually pulled up a light pollution map. The stars are pretty impressive at night, right? Do you guys ever stop and look at the stars?
Yeah.
All the time.
So you can see the Milky Way there, right?
Milky.
Yes? So what that means is that you have a front row seat to the entire shape and structure of the entire galaxy that we live in. And that's something that a lot of people don't appreciate. They just look up, oh, stars, and they go on with their lives. That is something that blew my mind every single time I'd go out into the Arizona desert. So I wanted to see more of it. I wanted to see specifically how much could I actually get a picture of this Milky Way galaxy. So this picture that I'm showing you with the cactus, this is a 25-second long exposure. If any of you do photography or take pictures with your phones, a typical photo with your phone camera is about a 60th or under 100th of a second long. Imagine keeping that shutter open and collecting light into your camera for 25 seconds long. You can pick up amazing detail and structure in the Milky Way. This is stuff that Galileo himself couldn't see. Galileo, one of the first astronomers to use the telescope, he couldn't see the detail that's in this photo. And here I am, just going out on a camping trip with my average backyard telescope and camera and doing amazing astronomy that Galileo would have killed for. So if you are interested in that, stick around. If you're not interested, stick around. I don't think your teacher's going to let you leave the room. So if we go on to slide number 5, I wanted to see what a galaxy looked like that we weren't inside of. You all see that little line, that blue line on the picture? That's actually called the Sombrero Galaxy. And I took that through my backyard telescope. This was an exposure that is, I think it was about an hour worth of light. So an entire hour of keeping the camera open, sucking in light through the telescope. And this, anybody have a guess for how far away this galaxy is? Any guess? Throw out a number.
A million.
A million what?
Light years. Light years.
So you are 1/30th of the way there. This is 30 million light years away. And it's crazy that this is what it looked like 30 million years ago, because it takes time for the light to get to us. Just like how you could see an explosion off in the distance and it takes time for that sound to get to you. This literally is an explosion of stars swirling around each other, and that light that's being emitted by that swirl isn't getting to us until 30 million years later. So this is what that galaxy looked like about the same time that the dinosaurs were roaming the Earth. Okay, raise your hand if a light bulb just went off in your head. I want you to understand that this is awesome stuff. Okay, one person in the back, thank you for paying attention. And so I learned that I could actually take really awesome, amazing photos with just backyard equipment. And I needed to teach myself. Nobody out there was there to tell me, oh, you have this setting wrong, you're pointing it in the wrong direction. So I did this like every weekend. And it was amazing that I finally found something as I was going through all these classes in school that I didn't care about. I found something for myself that was super invigorating, very involving. If we go on to slide 6. What does that look like? That's just simply a galaxy, right? Why is it so much bigger? Anybody have a guess? Why is it bigger than the other picture?
Oh.
Closer? It took more time.
So that is, the more time is excellent. This is actually a 4-hour-long exposure. However, that's not the reason why it looks bigger in the picture. The reason why it looks bigger is because it's only 2.5 million light years away instead of 30 million light years away. And so what if I told you you can see this nebula in the night sky without a telescope? Just simply looking with your naked eye, you can make out a smudgy star that is oblong, and what you're looking at, collecting light with your own eyeballs, is that galaxy. Of course, you wouldn't be able to see that detail. That detail is like that lady that said I collected more light. 4 hours worth of light to be able to get those swirls and those structures and the small little stars. Now, if you look closely, I don't know if your projector is good enough. There's a faint line starting in the upper left and going down sort of towards the center of the galaxy. Do you guys see that faint line?
Yes.
So that right there is actually a satellite. So during that 4-hour-long exposure, a satellite lit by our own sun drifted through the photo and left that line. So that satellite is actually a quarter of a light second away. It only takes a quarter of a second for light to bounce off that satellite and go into the telescope. And that thing behind the satellite is 2.5 million light years away. So a lot of people think that space is just something that you can only read about in the National Geographic magazine, different things. But to tell you the truth, you can just do it with a backyard telescope. You just might need to get your dad to buy you one first, which is the only reason I have a telescope. So moving on to slide number 7. Look at that color. You see that purple and that orange, the blues in there. I actually added the moon to that photo so you can see the actual size of the moon in relation to that nebula. So what you're looking at is a nebula. It's a huge cloud of dust and gas that's being heated and energized by the stars that are being born inside of it. And all of this stuff is happening and creating different colors, like all of the just colors across the whole spectrum. See that purple, that pink? It doesn't look pink or purple to you guys?
Pink, purple.
I think it's
Pink, purple? There's only one type of element in the entire universe that makes that color when it's heated, and we know that that's hydrogen. And so it's crazy that from the different colors coming in from these cosmic structures, we can know exactly what they're made out of. So that's something that I learned, is that I can just simply take this picture and I can learn exactly what I'm looking at, whether it's oxygen, hydrogen, sulfur, and that's something I taught myself over time. And if you can read these bullet points, I wasn't able to do this until I had broken my setup probably 4 or 5 times. I've been trial and error, I've been changing things, and this was probably 5 years long into my hobby. Do any of you guys play instruments? Anybody play the guitar, maybe a flute, cello? I would imagine that you are probably okay at your skill with the instruments, but imagine how good you're going to be 5 more years from now with that instrument. The only reason that I can take a photo like this is because I've been practicing with my instrument at the telescope for ages, and there's entire careers in science based off of people that are able to work with instruments and literally their skills with those instruments, whether it's a telescope or a microscope or it's a genetic test. There's amazing technology out there that still, even though the technology is amazing, it still takes a talented and skilled individual with that instrument to make music. And I personally love this about this scientific focused art, is that it's art at the end of the day. It's a beautiful picture, even though we're learning things from it, you can still make as much art as you want. Does that make sense? You know that analogy between art and science?
Yeah.
Does that make sense?
Yes.
Okay. So, moving on to slide number 8. It's that same rich purple-pink color. Who can tell me what this nebula is made out of?
Hydrogen.
Nailed it. So why would you think we would want to know what it's made out of? Like, why can't we just take a look at a pretty picture and know exactly, and just sort of stop there? Why does knowing what it's made out of help us?
Yeah, actually.
To know the type of gas that lives in space, or that like floats out there.
So a solid point. It's like if we know that the majority of stuff out there is actually made out of hydrogen, and then we can sort of pick up maybe some nitrogen, oxygen out there floating around, it might tell us that there's a possibility for life out there. Also, another thing that it tells us is we know that the Big Bang Theory, the theory that the entire universe came exploding apart from a single point in history and time, we can look all the way into the past and prove theories true or incorrect based off of what things are made out of. So the Big Bang Theory was literally proven true based off of the concentrations of different stuff in this nebula. But how long ago was the Big Bang Theory? Anybody know how long ago the Big Bang was?
Billion years?
Say it again?
A billion years ago?
So a million is a big number, right? Try 14 billion. B with a billion with a B. 14 billion years ago is how long ago the Big Bang is. And we know so much about the Big Bang. We know how long ago it was. We know how hot it was. We know in what directions and density the Big Bang was because of looking at simple small details in astronomy and space around us. Like simply the color of the nebula can tell us so much. All right, so this right here, this nebula is actually bigger than the full moon in the night sky. We can't see it because it is so dim. This right here, I believe, is a 2-hour-long exposure, sucking in light with my telescope for 2 hours so that you can get all that detail. You yourself, you could walk out. Do you guys know how to find the Orion Nebula? Orion constellation, you know, the one with the 3 stars in the belt. Do you guys remember that one at all, Orion?
Yeah.
Just the 3 stars in the belt. This whole picture right here is the sword that hangs down off of the belt. So if Orion, the great hunter, had a sword hanging there, you know exactly where to look to find this nebula. Next slide, slide number 9. So this right here is an example of something that you would never be able to see. To this day, I've never looked through a telescope and been able to see this. The only way that I was able to get this picture was I pointed it at a pitch black spot in the sky that my computer said, I think that's where the Horsehead Nebula is. And I took, this one was, I think, 2 hours worth of light collection. And then out of all of this information coming into the telescope, I did a lot of post-processing, and finally I was able to see this structure. All it is, look at it, it's nothing but dust. It's a shadow floating in the middle of space. And the only reason we can see it is there happens to be something giving off light behind it. And it blows my mind that we were able to see this thing to begin with. Like, it doesn't exist. there's no way that you can see it until you take a long exposure and see the absence of light. That's sort of poetic to me. I really love how just a guy with a telescope was able to take a picture of something like this. Do you guys see the faint lines going through this picture too?
Yeah.
There's one on the bottom, then another one sort of up through the top right. You see that faint line there?
Yeah.
Who can tell me what that is?
Satellite.
So what's special about these satellites is they're actually geostationary satellites. Okay, so take a look at that word, geostationary. Anybody have a guess on what that could possibly mean with geo and then stationary? Anyone?
It doesn't move.
Nailed it. So if it's stationary, it's actually staying in the exact position in relation to the Earth. So this satellite is staying still in the night sky. However, the stars behind it are moving. And so if I'm taking a photo for 2 hours, my telescope will have to move with the stars across the course of 2 hours, or else the stars are going to smear. Does that make sense? And it just so happens that the stars are moving, but that satellite wasn't. The satellite was staying perfectly still. And so it's sort of this optical illusion. The photo looks like everything is still when the satellite was moving. It's actually the opposite. The sky was moving, the telescope was moving, the satellite was staying still.
Are the stars moving or the Earth rotating?
Oh, perfect point. So it's all your frame of reference, right? So the Earth is spinning, the satellite is spinning with the Earth in perfect synchronous with the Earth, and the satellites are staying still. However, like Einstein said, it's all relativity, it's relative. Like if I'm running 50 miles per hour and you're running 60 next to me, it looks like you're moving 10 miles per hour. Who's to say who's wrong in that? But you're right, the Earth was moving. All right, so we're gonna finish off with slide number 10. And I know you all are on Instagram. Raise your hand if you're not on Twitter. Oh my gosh, Twitter is for old people apparently. How about Instagram? Raise your hand if you're on Instagram.
On or not?
On.
Okay, more people. Okay. So, I highly recommend you follow me so that way you can see my photos. I always try and put a scientific explanation. And when it comes to you trying to look impressive and cool in front of your friends and parents, I highly recommend you follow my channel. I'm not saying that it's going to be successful, because everybody has a different definition of what cool is. All right, you probably don't have your phones on you because it's not allowed. But moving on. Oh, you got them. Snap pictures then.
Can we?
What?
You found him?
Yeah, this is really so cool.
Yeah, isn't that cool? Look at this.
Yes. Do you guys have a favorite? Is there a favorite one on there?
Oh, I see him.
There's a favorite.
Yes.
Love them.
That picture actually took another 5 years for me to get all the different types of eclipses and put it together in Photoshop. Okay, so bottom line is, I want you guys to understand that even though these pictures are out of this world, crazy, awesome, whatever you want to call them, they are easily something that you can do if you want to. If you save up the money, if you put your effort towards it, by the time you're in college, I actually know several people that started this when they were like 12, 13, and I met them in college, and they were taking photos and selling them to magazines and making money off of this. And so it's a fun little hobby, and technology is finally at the point where anybody can do it. You don't have to be an astronomer on the top of the mountain to be able to do it. So if we move on to slide number 11.
Okay, let's put the phones away. Let's put them away. We gotta let it go. Let it go.
I opened a Pandora's box there, sorry.
Beautiful question. I didn't know. Oh, I follow me back. I have a lot. I got one. Say Kauffman.
Yeah,
Okay.
are you ready for questions?
You should follow us back.
You ready?
I think we got one in the back over there.
Let me put you back.
Okay, sure.
Oh, he's back.
We're back.
Hey, everybody.
Emma?
So I'm pretty sure there's like a black hole in space now or something. Have you like seen a black hole in space or anything, or like have you studied one?
So if I heard, the question is, have I ever seen a black hole?
Yeah.
So that is an excellent question for two reasons. I'll answer literally. I've taken pictures towards parts of the sky where I know that there's black holes, but I've never seen anything that would tell me that there's a black hole there. It's just like, sort of like an ocean of stars, and then I look at the exact pixels where the black hole should be, and it's just stars. So the truth is, the black hole is always going to be invisible. The black hole itself, there's no way that anybody could see it, because the definition of a black hole is light falls into it and never bounces off of it. Light can never escape after interacting with the event horizon of the black hole. So that doesn't mean that we haven't gotten a picture that shows a black hole. Sort of confusing, right? So recently, scientists and astronomers were able to use a network of telescopes across the entire surface of the Earth called the Event Horizon Telescope, and they collected terabytes, just thousands and thousands of terabytes of data of one black hole that's actually in a galaxy 50 million light years away. So they were able to zoom in on this one black hole, and what they were able to see was the burning and spiraling disk of material falling into the black hole. And so they saw this ring floating in the middle of space, and then in the very center of that ring where there's a black hole, nothing, just pitch black. And so it's amazing, to your question, still nobody to this day has ever seen a black hole, but we've actually been able to see the swirling masses of dust and gas that's on fire, emitting radio waves falling into a black hole. So yes and no. Excellent question.
Can it take our sun? Like, can it like
Eat our sun.
eat our sun?
So are you asking about the black hole they saw, or will our sun turn into a black hole? Can you...
Could a black hole take our sun?
Oh, easily. However, black holes can easily rip apart our entire solar system, fling Earth off into cold, dark space. We would all freeze to death. However, there is no black hole that we've ever seen that would come anywhere close to us. However, if a black hole flew past our solar system, it would easily destroy everything over the course of a couple of years. And we would barely even see it coming, because there's no light bouncing off of it. All the light comes into it, you wouldn't see it. And then before long, all of the planets would be flying off in random directions, and you'd see the sun getting sucked into it, and it would spiral into this whirlpool, and then it would just disappear. However, there is no reason to believe that will ever happen, because we can see the way things move around us, and the way that stars and planets orbit their stars, and we can see patterns of the drifting planets, stars around us. There's no signs that there's a black hole anywhere near us. So we're safe. However, they're very scary.
Ashley?
What happened to Pluto?
All right, so the question is, if you have a planet, then all of a sudden you learn that that planet is smaller than an asteroid, do you still call that small thing an asteroid? Let's say that you learn that your best friend, so you have a whole bunch of friends that are 8th grade, and it turns out that your favorite friend is actually a 7th grader. Do you still give him that honor of being in your group of friends? Or is he technically a 7th grader, so now he has to be a lesser friend? So that's a bad analogy, but no wonder there's so many people that have so many strong emotions about Pluto, because the truth is, Pluto was discovered, and they called it a planet, a very small planet. And then all of a sudden, out of nowhere, there's asteroids out there that are larger than Pluto itself. So if these asteroids get called asteroids, but they don't get called planets, then we got to rethink Pluto. Another thing that was the nail in the coffin for Pluto is the definition of a planet. You need to be the most large object in your orbit. So in the path around the sun, you got to make sure that Pluto controls everything in that orbit. Sadly, Pluto doesn't. Pluto goes across many different orbits of larger planets like Neptune. When it comes to a lot of the different asteroids that are in its orbit, Pluto doesn't really control them gravitationally. So that's what happened to Pluto. Pluto was discovered, and then we discovered more stuff, which turns out Pluto doesn't really classify as a planet. Was that too much information, or was that spot on?
I got it.
That was great.
Okay, good.
Yeah.
Again, in the back, I guess.
Emma?
Do you ever want to go to space? And
Oh, every day. Every day of my life, like I think of those 6 people sitting up on the space station. Of course, they're very busy, but imagine the view that they have. Like, I'm a photographer. I would absolutely die to get a picture of the Nile River flowing through the deserts of Egypt from 250 miles up. And that's stuff that only astronauts get to see, maybe a few pilots. But when it comes to the experiences that you can have as an astronaut, it's mind-blowing. And mark my words, all of you in this room, like each and every one of you, like you're 8th graders right now, imagine the opportunities you're gonna have in 20 years from now. So think of the careers. Like right now, SpaceX in Los Angeles, they're building brand new rockets that are designed to take 100 people to space at a time. When the most that's ever been able to go in one rocket at a time was 7 people in the space shuttle. So imagine if all of a sudden the price to entry of going to space drops dramatically. By the time you're having kids, who knows, maybe it's going to be cheaper than, you know, a flight to Europe to go to space. You can actually have a honeymoon to the moon. But at this point, I don't think the odds for me are all that great, maybe when I retire, but I think you guys have a better shot of just being a casual astronaut than I do.
Anya?
How much was the camera?
You mean when he was a child?
How much?
Like
How
a
much
telescope.
telescope? How much?
Oh, like the picture of the telescope, like slide 10? Which one was that?
Yeah.
So do you want like the brand, or do you want like the technical specs? Because I can talk shop with you all day.
Brand.
So it's a Celestron. It's the Celestron 925 Edge HD. And then the mount is the CGX. So if what you're really asking is how expensive is that telescope,
Yes.
so that you can look it up, it's about $3,500. So it's the price of a really cheap car.
A really
And
cheap
I saved for like, I think it was 10 years I was saving for that telescope.
Can I say?
Carrie?
Okay. How do astronauts know when it's day or night when they're up there?
So the way that it's day or night, like, is that defined by is the sun shining on you, or is it when you're in the shadow of the Earth?
When
So
it's
that's a question that goes back and forth, because if you're on the surface of the Earth, obviously, if the sun is shining on you, it's daytime. But astronauts, they're going around through the shadow of the Earth every 90 minutes. Like an hour and a half is how long the day lasts on the International Space Station. So the truth is, they just have clocks. And when it hits, 9, 10 o'clock at night in Central Time, Greenwich, England is the central time zone for the planet Earth. I think they go off of that time period. When it's 9 o'clock at night, they just go to sleep, and then when they wake up, they've already seen the sun whiz past them easily, I think it's 5, 6 times. So there's no way that you can go off of the sun or darkness to know what time of day it is. It's only clocks that you have to go by.
Annalyn?
How do you decide where to point the telescope?
So there's a reason I saved up $3,500 for that telescope. It's because all I have to do is take the telescope, point it north, tell it, like in the computer on the telescope, tell it where on the Earth it is, say that it's in Phoenix, Arizona. And then I tell it the time, the day, and then I point it to 2 different stars. And from that information, it has a catalog of 40,000 different objects in the sky that it knows where to look. So I can literally say, point at Jupiter, and we'll go right over and look dead on, straight on Jupiter. So that right there sounds like a lot of money, but the truth is, if you take any telescope and add maybe $200-300 to the price, it should be able to do the same thing.
Orion?
Oh, what's your favorite planet?
Earth, by far. Earth is phenomenal. Just the other day I went to Japan and I saw mountains and forests, and I actually in Japan stumbled across a ice cave. Like I was hiking in the Suicide Forest, that's what it's called, the Suicide Forest. And then I was hiking around and I saw an ice cave, and I climbed down in it and there was stalactites made out of ice everywhere, and I took pictures. I'll post them to Instagram. So there's nowhere else that I could do that and survive easily. The second that we could go to Mars and do that, that'd be fun. But in the meantime, Earth is my favorite for now.
Emma?
Do you ever think there's gonna be like another Earth or planet we can live on?
She wants to
Say
know,
again, another Earth?
or another planet that would be habitable for humans.
Ooh, now are you talking about like we all live inside of a bubble where we're safe from the elements, or are we talking about the planet just walking around outside is livable?
Livable outside.
Both.
Both.
Well, perfect. So there's a big push and a huge goal to terraform Mars. Terraform, big word. Imagine if you were able to pump, you know how on Earth we're pumping a whole bunch of carbon dioxide into our atmosphere and it's heating the planet, sort of like global warming. Are you guys familiar with that?
Yeah. Our next unit.
Perfect. So keep that in mind. There's actually a lot of people saying that we can use the same type of interactions with our environment to start heating Mars up to the point where the atmosphere is comparable to Earth's. But easily that's going to take probably hundreds of thousands of years to do. But what happens if an asteroid takes out Earth? Literally, an asteroid, if not a black hole, could swing by and destroy Earth as we know it. So that is the whole argument that people think we need to invest hundreds of thousands of dollars, hundreds of thousands of years, and who knows how many billions of dollars into making Mars a habitable planet. Of course, I see people laughing in the background here, but I have to say, entire companies have been devoted to making humans live on the surface of Mars. And honestly, that's SpaceX. If you've heard on Elon Musk, that is his #1 goal, is to make humans living on the surface of Mars a reality. And I'm a believer. I'm going to say I believe it's going to happen.
I was laughing at the catastrophic possible events to destroy Earth.
But that's why I love astronomy, is because literally if you're doing any other study of like, oh, let's look at ecosystems, let's look at finances, it's all pretty standard stuff. The second you start studying astronomy, like, who knows what's going to happen? Astronomy is just out the window right now.
Hanya?
That's a solid question. To tell you the truth, I make a medium range. I am just below 6 figures, so I make what, $90,000. But yes, that may sound like a lot of money. Living in Los Angeles is one of the most expensive places to live on the planet. I think San Francisco might be more expensive, and so even though I make a really nice paycheck, all of that money disappears to rent. And so even though I've been saving up for the telescope and I went on a trip to Japan, I've had to save for these things for the last, 2-3 years to be able to do these things. So at the exact same time, being an engineer is nice because you get that paycheck. It all depends on how you make it work. You still need to be a smart budgeter in the meantime.
Emma?
But like, back to the another Earth thing. Do you think like far, far away from us there might be another Earth?
Perfect question. So another Earth, we know for sure that there are rocks, planets our size, in an orbit around a star that allows for liquid water. It's not too close, so the water doesn't boil off, and it's not too far, so the water freezes. So we know for a fact that there's planets out there our size in what we call the Goldilocks zone, just perfect. What we do not know is if those planets have life. And that's actually something that a new space telescope is working towards. If we can use the James Webb Space Telescope to actually collect colors from those other planets, we might be able to look at the spectrum and colors from those other planets' atmospheres and see if there's large amounts of methane, then that means there's probably a lot of life on that planet. But definitively to know for sure or not if that other planet is like a duplicate of Earth with all these people living on it or not, it's going to be probably centuries before we're able to tell.
Jim, do you have a question?
I can ask it.
Yeah, sure. What if there's such thing as a
With a planet like Saturn, because it has so many moons, are there more eclipses?
Ooh, excellent question. That is absolutely the case. If you were floating on the surface of Saturn, especially at the equator, you would easily see 3 to 4 eclipses a day. These really big moons called the Galilean moons, Io, Europa, Callisto, and Ganymede, they swing around the entire planet Jupiter in timescales that are close to a day. Like they swing around in, I think it's a day and a half, something like that. So you could see tons of different eclipses happening all the time, but the problem is Saturn is made out of gas and you fall right through it and die. So that's fine. So I actually only have a couple more minutes. I gotta head off to a meeting coming up pretty soon. I'll leave it up to Amanda to decide specifically how she wants to deal with the time.
Are there any more questions? Can we do one last question?
Yeah.
Actually,
Or do you need to go right now?
Coming up pretty soon, maybe 5 minutes.
Okay.
We have 5 minutes. We're good.
when's the next solar eclipse gonna happen?
We can look that up. We can look that up.
Yeah.
Ashley?
If you had an apple and you threw it in space, would it explode or would it rot? Because like there's no space for it to rot.
Discuss this.
Well, Ms. Kauffman didn't answer. You said some possible things can happen.
I mean, if something goes into space, what happens?
No, it's like if you had an apple, like a fresh apple.
Like the fruit, the apple, if
Yeah.
it just is floating in space, will it explode?
Will it rot?
The answer true is it will explode microscopically. The apple itself will stay in one piece, but it'll do something called outgassing. All the fluids, all the water inside the apple, since there's no pressure, it'll turn to gas instantly. And so the gas will sort of fizz out of the apple, but it won't be strong enough to make it explode. Will it rot? No, it'll stay frozen for the rest of eternity, and it'll look like a perfect apple with the skin slightly shriveled a little bit from that gas escaping. It'll float through the vacuum of space forever without ever rotting.
Would you guys eat it?
Wow.
Okay, one last question.
Would you guys eat the apple?
One last question.
What happened if you ate it? What do you think it would gas and
Do you
stuff?
break your teeth?
Oh, what?
Do you have a real question? Okay,
We have one.
go ahead.
Alright. What is the, like, what if you fell in a black hole? What
Okay,
happened?
we covered that already.
We already
Okay, thank you so much for your time. Everyone, thank you.
Yeah, I have last.
Thanks for using your lunch.
Yeah, very well.
Is there a rat?
Very well.